Good afternoon, everyone out there tuning in for another edition of National Museum of Industrial History's virtual museum. Thanks so much for joining us. If you've been with us, you know that we've been putting on a whole host of content. We have about 30 hours of live industrial lectures that we hosted, continuing that program. Today we have Tom Fehring. We also have a couple programs coming up. For those of you who don't follow us, please check us out on Facebook if you're watching this, or you can check us out at nmih.org, which is our website. We have a couple different talks coming up. One is tomorrow about a crane in the museum, and on Tuesday we're hosting a live virtual tour with we have a large Allis-Chalmers engine, which Tom, I think, will be talking about that company during his lecture today. Also, if you're watching at home, you know that you're seeing, and there's a couple different ways that you can help out the National Museum of Industrial History while we're shut down right now. If you'd like to find out more, we're going to be posting a link down in the comments in a couple minutes, or again, you can head to nmih.org. Some of the ways that you can help are if you're shopping at Amazon while you're at home, you can use Amazon Smile, and a portion of your proceeds will go to the museum. You can buy a museum membership, and a program that we're launching just now is a program where if you buy a membership, we're also providing a free family membership to someone from our local healthcare community. So you're not only getting a museum membership, but you're also helping someone out who's been helping our community during this pandemic. So again, there will be a link in the comments shortly, or you can head to our website at nmih.org, find out ways to help us, and also keep tabs on our upcoming programs. Without further ado, I'd like to introduce Tom Fehring. He's an engineer by training and practice, and he worked for 35 years at Wisconsin Energy Corporation and its subsidiaries. Earlier in his career, he also worked at the Falk Corporation, Briggs and Stratton, and the Ford Motor Company. He's a graduate with his master's and bachelor's from Marquette University in mechanical engineering, and he began his interest in industrial history 40 years ago and has subsequently been appointed as part of the History and Heritage Committee of the American Society of Mechanical Engineers. If anyone from that organization out there is watching, we also appreciate you guys getting the word out about this this talk. You guys have been great. And without further ado, I'm going to pass it over to Tom. Thanks, Tom.
Well, thank you very, very much. Okay, let me share my screen and bring up the presentation. I assume, Glenn, you'll have to let me know. I assume everybody can see the first slide here, which is the, okay, it's the gauge face of the Phillipsburg triple expansion steam engine. And, you know, I was asked today to talk about two subjects that are tied to the National Museum of Industrial History. Allis-Chalmers, which manufactured the Phillipsburg steam engine, and Pawling and Harnischfeger, which manufactured the overhead crane that's actually as part of the National Museum of Industrial History. I believe that overhead crane, you walk under it as you walk through the entranceway at the museum. And it's kind of nice because there are close ties. They were both manufactured, both Milwaukee manufacturers. And as you'll see in a few minutes, these two companies are really intertwined. And technology flowed from one to the other. And I'll explain that in just a few minutes. I've been studying Milwaukee's industrial heritage for a little over 40 years. And have been taking a rather different approach. You know, I'm not a historian by training. You know, the history of technology is really my hobby. And as a result of that, you know, the approach that I took is to explore the innovation, the history of innovation in the Milwaukee area. Milwaukee, of course, was one of the industrial centers and continues to be an industrial center in the United States. And there's a lot of interesting history that a history of innovation and enterprise creation. And you know, largely during the 40 years of my investigation, I've been studying the significant engineering accomplishments that have occurred in the Milwaukee area. And then more recently, when I decided to begin to document all of this as part of the book, then I started, you know, exploring some other ties, how these companies were interrelated in some ways, and how their location and proximity to one another aided the whole environment of innovation in Milwaukee. And I'll try to explain that a little bit as we get into it. But let's start the, make sure I click the right buttons here. So about 3 years ago, I published a book called Magnificent Machines of Milwaukee. And the book chronicles Milwaukee's industrial achievement, focusing on what I call the century of progress, really starting with the U.S. Civil War going for 100 years, and concentrating on some of the incredible machines that were built in the Milwaukee area, and highlighting the people that really were behind those machines. Who are the innovators? How did they get started in that activity? And then how did their innovation lead to the formation of companies? And then I sum it all up. The last chapter of the book tries to provide some insights. Why was that period of time in Milwaukee so incredibly innovative, and how did we lose that over the time, and how can we get that environment back again? So that's essentially what the book describes, and it covers about 70 some companies. What I'm going to do, of course, is just concentrate largely on Allis-Chalmers and Pawling Harnischfeger. But before getting to them, I thought it'd be helpful just to give a little bit of the genesis of industrial technology in Milwaukee. It really all goes back to an ill-fated canal, an attempt to build a canal. Of course, the most successful canal, I believe, in the United States is the Erie Canal, and really, which provided it kind of opened access from eastern part of the United States, New York in particular, to the Great Lakes. And by opening that canal, of course, that provided access from the East Coast to Milwaukee, which is connected to the Great Lakes. And Byron Kilbourne and Increase Lapham, two gentlemen who are very, very well known in Milwaukee, they both came to Milwaukee having previously worked on the Erie Canal and several other canal projects. And their main motivation in coming to Milwaukee was to build a canal that would have gone from the city of Milwaukee, which has a great port on Lake Michigan, and that would taken that canal further west to join with the Rock River. And the Rock River eventually empties into the Mississippi. So had they been successful, this canal would have provided a water circuit all the way from the eastern part of the New York, through the Great Lakes, through this Milwaukee and Rock River Canal system, down the Mississippi, all the way to the Gulf. And it could have been, a real plus for Milwaukee and the like. But before they got too far, they only completed about a mile of this canal, and two things got in their way. One is the original construction costs were higher than what they anticipated. They ran into rock strata. So the first mile that they built was very costly. But then the second thing that really got in the way, and you can see it in this image, and I don't know if my cursor is viewable, but you can see a train coming down the tracks. By the time they get started in 1839, they were very close to the era in which railway transportation became more available and affordable than canal traffic, which up until that time, of course, was the only major transportation available. And because of that, they immediately turned their attention toward railway expansion. And as a result of this, the canal was only about a mile or so was completed. But this canal became very important to Milwaukee industry. And the reason for that is this 1 mile stretch. And you can see the canal on the left side here. The Milwaukee River is off on the right side. The canal, of course, is served by water that's above the dam, so that the water level in the canal is higher than the water level in Milwaukee River. And anytime you've got a significant head difference, you've got the potential for water power. So by 1843, there were companies that were located along a narrow strip of land. I'll show you another view of that. And again, I don't know if my cursor is visible, but you can see, if you can follow my cursor, you can see the canal in the right top quadrant here, Milwaukee River down below, and you can see a number of companies that were located in that narrow strip of land, most of which were water powered. And we don't know much about those companies. You know, certainly there were flour mills, other grist mills. There was at least one company, though. There was the Briggs and Smith mill that I don't know if it was originally designed for to provide line shaft use and the like for machinery, for the production of machinery or not, but that's what it evolved to. And before long, James Paris Lee was using that site to make firearms. He had some success in Milwaukee. Ultimately, decided, however, to go to Remington Corporation, and Remington hired him, and he went on to be a very, very famous gun designer. He was significantly known for the creation of the first usable cartridge style magazines for rifles. And then the development of the typewriter, the Scholes and Glidden typewriter, was actually initially manufactured on a mill located right around here, that same mill that James Paris Lee had one time used as a manufacturer. And then ultimately, the Scholes and Glidden Corporation decided to outsource their construction to Remington, and the further development of the typewriter then moved east to Remington. But at least that's the start. That's the genesis of industry in Milwaukee. Eventually, other industries located around the banks of the Milwaukee River. If you see, here's another view, and the companies that I was talking about are on the far west end, far left end of the screen. But if you go down the river a little bit, you see a number of companies located on the banks of the Milwaukee River, and you see smokestacks for the first time. And of course, what was occurring is that when you get into the 1850s, steam power became available, the technology became affordable, and you no longer had to be located on a hydro site in order to have a motive power for manufacturing. One of the companies located in that area was a company owned by Decker and Seville, and it was known as the Reliance Works. And you can see from this image, the Reliance Works was involved in mill furnishings and millstones and general blacksmith activities and the like. And they ultimately failed. In 1861, Edward P. Ellis, and of course that's where the Allis-Chalmers name comes from. Ellis P. Ellis acquires that works in a fire sale.
Tom, I think you accidentally muted yourself.
There we go.
There you go.
Okay, I apologize for that. So you missed a little bit. Well, I
Not too much.
apologize for that. You can see this line that occurred while I was muted. You know, one of the first things that Edward Ellis did after he acquired the Decker and Seville factories, he decided, because they were landlocked and he had great vision for the future of the company, decided that he needed really to move the factory. And what he did is he literally floated their principal buildings down the Milwaukee River, moved it to a site right on the east side. Walker's Point is the area that we referred to. And as a result of that, you know, the Walker's Point area became a center of manufacturing in Milwaukee. and a very significant center of manufacturing. If you can see this view, and I love some of these illustrated maps of Milwaukee. This is EP Ellis at the time, if you can see my cursor again, and you can see all of these other companies located in the general proximity. There were also individual residents. You know, this was a neighborhood, an industrial neighborhood where people could walk to work. There were churches you can actually see in some of the images, and there's certainly were bars, grocery stores, all the types of things that a neighborhood would have, plus industry. And because of that, you know, the proximity of all of these companies, let me show you the names of some of the principal companies that were located in this general area. There was a lot of innovation that flowed from company to company. You know, you can almost envision people, you know, perhaps after work at the local bar sharing their stories about what was going on in their company and their problems. And anytime you've got that type of environment, information flows. People say, well, have you tried this? Have you tried, or in my company, we've done this, that sort of stuff. And there's numerous illustrations of the linkages that occurred between these companies. I'm only going to explore 2 linkages, and they're all involved right in this area where EP Ellis, you can see on the map, Ellen Bradley and Pawling and Harnischfeger. And if you look, these companies were located right across the street from one another. So let's get to those linkages. You know, first of all, this is the Reliance Works, the original buildings that were floated downstream or showed at the far left. And of course, EP Ellis expanded his facility pretty quickly. And the way he expanded, he decided he needed to hire the brightest and the best talent available at that time. And he acquired the services of Edwin Reynolds, of George Hinckley, and William Dixon Gray. And why was that important? Well, Reynolds came out of the Corliss organization. He was the chief engineer for Corliss, certainly knew steam engines and knew the design of a lot of the equipment that's powered by steam engines. George Hinckley was involved in lumber mill equipment, and William Dixon Gray was involved in flour mills. And you know, if you can envision what Milwaukee might have looked like at that time, you had lumber rather coming from the North Woods, eventually making its way into Milwaukee or into cities along the way. And that lumber needed to be sawed, needed to be cut into suitable lengths, needed to be milled, all that sort of stuff. So the equipment that Hinckley brought to the table was very important. And of course, then he had farms located throughout the Midwest that, you know, producing flour, producing other grains that needed to be milled. And so you needed suitable mills to do that. And William Dixon Gray was the first to develop the roller mill. Hinckley developed the bandsaw, and Edwin Reynolds was probably the foremost designer of steam engines in the era. And so how did that happen? How did, you know, this obscure small company in Milwaukee attract the talent of these 3 individuals? EP Ellis did something pretty unusual. He told these gentlemen, he says, you know, if you come and work for me, I'll allow you to continue to own your patents, and I'll pay you for the use of those patents. So he was actually able to acquire the services of Edwin Reynolds, for example, by paying him less than what Reynolds had made previous to that, working at the Corliss organization. But he would realize the continued royalty for use of his patents, which of course encouraged all 3 of these men to develop additional patents and the like. Pretty quickly on, EP Ellis acquired the services of a number of other individuals: Bruno Nordberg, Niles Christensen, Ole Evinrude, William Trout. Are just 4 rather of very significant engineers that worked for the company. Over time, 3 of them went on to form their own corporations. Niles Christensen developed an air brake for streetcars. Ole Evinrude, of course, you probably recognize his name as being tied with outboards. Bruno Nordberg developed a company that ended up being pretty much in competition with Allis-Chalmers, manufacturing a lot of the same type of equipment, steam engines initially, and then diesels and other heavy equipment. The second thing that Reynolds did is he allowed his principal engineers to brand the equipment that they developed, put their names on the equipment, if you would. So the steam engines that were sold by E.P. Allis and eventually Allis-Chalmers generally were referred to as Reynolds coreless engines. There were improved coreless designs by Edwin Reynolds. So, you know, the advertising for the equipment, the name tags for the equipment, in many cases talked about it as being a Reynolds engine. Similarly, roller mills had Gray's name on it. Trout developed the power set works, which was very important in lumber mills, you know, to essentially set the thickness of the board that is being cut, and ended up being pretty universally developed. And of course, the bandsaw was very important. But in all cases, you know, the names that were going on that equipment, you know, rather than the principal name being Allis-Chalmers or E.P. Allis, you know, was the name of the designer, which was really unheard of at that time. And I think it was pretty innovative by E.P. Allis in attracting the talent that he needed in order to expand the company. So expand they did, and they did quite well. This is an illustration of the inside of the Reliance Works. Not sure exactly what period of time, but this was probably 1870s, 1890s or something. And the reason I wanted to show this is you can see the original overhead crane. And the story is at some point, this overhead crane failed, and E.P. Allis took aside one of the young engineers at that time, a guy named Elton Shaw, and said, hey, investigate why this crane failed, get it back into service. And, you know, you can't really operate a facility like this without a suitable overhead crane. And Elton Shaw went beyond that. He ultimately developed a new style of overhead crane. You can see his 1890 patent drawing. And his innovation was really to electrically power the overhead crane. Before then, overhead cranes were largely, you know, rope and tackle and you know, physically moving the crane up and down the tracks and stuff like that, using cables and the like. You can see, you know, the three forms of motion of the crane. You know, of course, there's an electric motor located up here to cause the winch to go up, the hoist to go up and down. There's another electric motor that takes this trolley that runs across the crane to move the trolley, you know, left and right across the crane. And then a third electric motor, which was coupled to a shaft that actually ran all the length of the crane to power the crane up and down the factory floor. So he gets a patent for this. E.P. Allis at that time, they had so much business producing steam engines and blowers and pumps and compressors and all the things that you use a steam engine to drive, that they weren't interested in getting into the crane business. So lo and behold, you know, Shaw walks across the street to Pawling and Harnischfeger and asks Pawling and Harnischfeger if they would be interested in producing overhead cranes. Now, Pawling and Harnischfeger at that point was a job shop. They didn't have a product of their own. You know, they provided services to other manufacturers that were located in that neighborhood, one of which was E.P. Allis at the time. And, you know, they were delighted with the prospect of also working on overhead cranes, and that's what launched them into the overhead crane business. Now, they didn't, you know, as innovative as this overhead crane setup was with Elton Shaw's patent and all that, he needed one other thing to make it work, and he needed a suitable control system. And that brings us to, you know, what at the time was called the Compression Rheostat Company, eventually became Ellen Bradley. Lined Bradley who was a very young engineer, had developed a compression rheostat device. Now, I don't even know what caused him to do this, but he determined that if you took a stack of carbon discs and then compressed that stack of discs, that the flow of electricity would increase. And the more compression you put on the stack, the faster the electricity would flow. And if you would relieve the pressure, of course, the electricity flow through the stack would eventually stop. And that device provided rheostat control. It provided the ability to feather, if you will, to slowly start a motor and bring it to full speed. And as you can imagine, that would be very, very important in controlling an overhead crane. In an overhead crane, if all you were doing is throwing a knife switch to start the motors and stop the motors, the things would be jerking all over the place. And if you watch a crane operator that knows what he's doing, they're able to place the load very lightly and just drop it right exactly where it needs to go. There's no jerkiness associated with any of that. So they needed the control device that Allen-Bradley was able to provide. And again, these three companies were located literally across the street from one another. And so that's how Pawling and Harnischfeger got in the crane business. Elton Shaw actually went on to develop his own company. So he's using Pawling and Harnischfeger initially to manufacture cranes and components, really for himself. He goes and forms a company, ultimately moves to Michigan. Pawling and Harnischfeger still was doing some activity, I believe, for Shaw's company. Eventually patents ran out, and Pawling and Harnischfeger concentrated on crane business, and I'll explain that a little further. This is Pawling and Harnischfeger's facility located in the late 1800s, and again, this is across the street from the E.P. Allis factory. I like this view. It shows not only an overhead crane at the top of the screen that spanned the width of the factory floor, but a jib crane underneath it. And in many cases, factories had both jib cranes and overhead cranes. The jib cranes could be used for, like in this case, there's probably molten metal being moved in moved underneath this, being moved for castings and the like, whereas the overhead crane was being used to move major equipment. In both cases, you'll see they're operating using a compression rheostat designed by Allen-Bradley, and back in the day, and I think even when I started in business, it was normal for the crane operators to travel along with the cranes themselves. Now I'm going to move to Allis-Chalmers a little bit. And you'll note I use E.P. Allis and Allis-Chalmers kind of interchangeably in a lot of cases. I'll try to stay correct for that if I could. This image shown here is the Milwaukee Waterworks plant that was designed around using E.P. Allis steam engines, located right on the lakefront of the city of Milwaukee. You can see an innovative, rather fancy looking tower located on the hill. That hill is probably 120 feet or so above the lake level, and that tower, all it contained was a standpipe, and that standpipe was designed to kind of accommodate the pulsing that occurred in the steam driven pump system. That plant was designed to use a triple expansion pumping engine that was designed by E.P. Allis. E.P. Allis eventually built over 100 such water pumping engines, got to be very, very well known in the industry for that. What really led them to success, however, I think, was their North Point pumping station, which was developed I believe in I may have the wrong date here, in 1891. And it was designed by Reynolds, but it was designed by Irving Reynolds. Irving was the nephew of Edwin Reynolds, and Edwin brought him in to assist him in the design activities. this pumping station was the most efficient pumping station in the world at the time. And when they began advertising about the capabilities and the efficiency of this, largely the industry pushed back and said, we don't really believe that you could produce a pumping engine with this efficiency. And ultimately, Robert Thurston, Dr. Thurston from Cornell, came in to test the engine and documented it in a technical paper, and proved that the engine indeed was as efficient as it was. And the advertising from all that activity, of course, led to a lot of orders for triple expansion pumping engines from Allis-Chalmers or EP Ellis at the time, and very, very successful installation, and led to orders from all over the place. Here, for example, is an order that was acquired from City of Chicago's municipal system, just one of well over 100 of those huge steam engines. Here's another application. The city of Milwaukee, over time, was flushing a lot of its sewerage into the Milwaukee River, and during the summer months in particular, the Milwaukee River became a cesspool. The engineers at that time from the city of Milwaukee decided that the fix to that was to flush the Milwaukee River system, so that the acronym that's typically used is the solution to pollution is dilution, and that's really what was their intention by through this installation. They hired EP Ellis to design a pump. The pump at the time was the largest capacity pump in the world. It was a horizontal screw pump, as you can see in this illustration here. It was recognized as a landmark by ASME in 1992. The facility has actually become a landmark for the city of Milwaukee, if you will. This is the location of that pump. And it's currently a coffee house, very, very popular, right on the lakefront of the city of Milwaukee. One half of that pump house, if you would, is where the boiler was located, the boiler room, and that's really become the coffee house proper. And if you look on the other side of the wall, the original pump is still installed. The steam engine's been replaced with an electric-driven motor and a Falk gear drive, but it's still used to this day in the summer months, where if the oxygen level in the Milwaukee River becomes too low, it's pressed into service to take fresh water from Lake Michigan and cause it to be added to this more stagnant river water. Very successful installation. The Chapin mine pump in 1893, also given a landmark status by the American Society of Mechanical Engineers. This pump, the Chapin mine, was I believe a copper mine, very, very deep mine and very wet mine, so it needed to be dewatered. They turned to Edwin Reynolds to develop this dewatering engine, and let me see if I can find some of the particulars on that. The engine of its, at the time, it was the largest of its type ever constructed. There were 10 pumps rather, that were all installed on a vertical shaft, 8 set at intervals of 192 feet and 2 at intervals of 170 feet. So it went all the way down 1,500 feet below the surface, and the overall device had a pumping capacity of 3,400 gallons per minute, which was sufficient to dewater the Chapin mine. Edwin Reynolds also designed the steam engine that powered the Columbian Exposition in Chicago, and again, this engine probably gave Edwin Reynolds and EP Ellis the most publicity of all because of the successful installation. And he also developed the first steam engines that directly drove generator, the magnetic poles in the flywheel, if you will. And you know, once this innovation occurred, then all manufacturers began to direct drive. You see the previous installation, the generators are driven, which was conventional at that time, were driven separately on separate shafts and belts, and to be able to drive the generator windings directly, of course, provided economy and also provided space economy, if you will. And that got very, very important when it came to powering the electric line, the electric, you know, essentially the subway system in New York. You know, New York, as they were developing their electric transportation corridor and the subway system, they needed a way in which to electrify it, and they didn't have much space. And they ended up turning to Edwin Reynolds to design their steam engines. These were very innovative steam engines. At the time, it was a combination vertical horizontal engine, whereas the high pressure cylinders were horizontal, and the low pressure cylinders were vertical, in order to provide a compact design. And you can see also, going along with the compact design, there was a single flywheel generator located between two sets, so that you know, there were tandem compound units, if you will. So you got 1, 2, 3, 4, 5, 6, 7, 8, all located, 8 tandem compound units. And he built 2 of these plants for the City of New York transportation system. The practice of EPLS at the time, and it continued, I think, all during the tenure of Allis-Chalmers and like, was to pre-assemble the components for shipping them out. So this was the pre-assembling shown on screen here in the factory in Milwaukee before it was shipped to New York. Edwin Reynolds was also involved in designing blowing engines. I believe he was the first to begin using cast iron valves that replaced the leather valves that were used before that on the actual blower compressors themselves, and led to a lot of orders for EPLS. Now, you know, eventually, even though the Walker's Point area in the city of Milwaukee provided a lot of additional space, they eventually became landlocked. And again, and especially after the merger, EPLS merged with the Chalmers Corporation out of Chicago, moved operations to Milwaukee, needed additional space. And a lot of the other companies that were located in this area needed additional space originally. So this is the, you know, I believe I showed this area on a map earlier, where all of these companies were located literally within blocks of one another in the Walker's Point area of Milwaukee. They almost all began moving from that area, and they followed the railroad lines. And in the case of Pawling and Harnischfeger and EPLS, they moved west to the community that eventually became known as West Allis, because it was the West factory for Allis-Chalmers, if you would. And the community itself developed the name West Allis. And Pawling and Harnischfeger moved to the community of West Milwaukee. So following that move, some of the interrelations that went on between the companies began to deteriorate, and that's one of the things I wanted to document in the book. But in any case, this is the factory that was built by Pawling and Harnischfeger in West Milwaukee as they expanded. I'll show some other images of that in a few minutes. Pawling and Harnischfeger continued in the overhead crane business, developed some pretty innovative overhead cranes, and of course specialties like this one for hauling lumber and sheet steel and various other things like that. And of course, eventually controls were developed so that the crane operator no longer needed to travel along with the overhead crane and could actually more safely and securely move the move the load by being located right on the space where the load was being transferred. They also got into mining business, and the first machine that got them into the mining business was a ladder type trench excavator. That was followed by a more sophisticated excavator. And really the company then, largely is morphed into a mining equipment company, producing shovels and other excavation equipment. This is an interior shot of the principal assembly floor at Pawling and Harnischfeger, and you can see, at least at that point, it was very, very busy. Pawling and Harnischfeger today is continues to be located in West Milwaukee. They were acquired by Joy Global at one point and became their mining division. Joy Global's mining division was more recently acquired by Komatsu, and continues to be Komatsu's headquarters of its mining division. Interestingly enough, they're in the process of relocating their operations very close to where they originally got started in the Walker's Point area. They'll be a little bit south of that location, but very, very close. They're in the process of building a brand new facility. Allis-Chalmers, of course, they moved their factory to this new community of Greenfield. Initially, they, now it's it was renamed West Allis because of the significance of their factory moving to the west. The facility was designed by Edwin Reynolds. It was designed to be the most efficient factory in the United States, where the engineering and the drafting activities would be, performed on the far west end of the site, and the casting activities and other material assembly or at least material aggregating all coming together was just to the east of that. And then you can see these rows of individual factories where things like engines were assembled, or turbine blading or generator components and the like, all on its way to this final assembly building located on the far east end of the site. I'm just going to show you just some of the things that were created at this facility of significance. Here's hydro turbine equipment developed for Niagara Falls. Very innovative and for its time, the largest hydro facilities. Just to give you an idea of the scope, here's I believe a Model T Ford located, adjacent to the steel spiral casing for one of the facilities at Niagara. And you can see how, again, it was pre-assembled on the factory floor in West Allis before being shipped out to make sure that everything was going to fit properly. They eventually produced most of the hydro turbines for the Hoover Dam. This is just a tour of the floor, and of course, this is the generator winding at this location, the spiral casing and the like, and the turbine proper itself. The mechanicals are down, located on the floor below that. The Hiawassee pump storage facility was quite significant. This is the stator assembly itself. You can see these three gentlemen standing located in here. I'm sure this was staged for the photograph. And you can see the stacked wicket gates sitting here in the background. These units, of course, would be matched. The significance of Hiawassee, it was a pump storage facility. So at night, the unit was run as a pump, and it would pump water from the river up into the reservoir. And then during the daytime, when electric power usage was higher, then you would run it as a conventional hydro facility in which the water would flow through the turbine and produce electricity. Because of its significance, it was also recognized as a landmark by ASME. This facility, actually built in 1924, was recognized as the most efficient triple expansion steam engine ever produced. It's kind of surprising because, to produce it in 1924, this was really getting beyond the steam age for pumping stations. Water pumping stations at this point were almost always powered by electric motors. But the city of Milwaukee engineers at that time looked into the characteristics of both, decided to select a steam engine produced by Allis-Chalmers, and it was documented at that point it was the most efficient steam engine. The facility still remains in service, but the steam engine's been replaced by electric motors eventually. And I'm not really sure how many years it stayed in service as a coal-fired steam engine before it was retired. And unfortunately, the beautiful facility, when they replaced it with steam engines, replaced the steam engines with electric motors. They took out the steam engines, which is a real shame. Allis-Chalmers also manufactured the most efficient turbine generator at its time as they began getting into steam turbine designs. This facility, also recognized as a landmark by ASME, was located in the city of Port Washington, just north of the city of Milwaukee. And it was an 80 megawatt unit. Eventually, 5 80 megawatt units were all installed, all using very similar engines, similar turbine generators. And again, this is an assembly being pre-staged at the factory in West Allis before it was shipped to site in Port Washington. Allis-Chalmers also manufactured what was known as Big Alice in Ravenswood for the Con Ed system. This was a 1,000 megawatt unit. It was a compound unit. The low pressure units ran on one shaft. The high pressure steam turbines ran on another shaft, different speeds, I believe. I believe the high pressure ran at 3,600, whereas the low pressure units ran at 1,800 RPM. This unit had a lot of notoriety. There were issues, I believe, at some point early on in the life of the unit. The lubricating pumps failed. And as a result of that, that led to bearing failures and a significant outage. And because it was a 1,000 megawatt unit supplying the city of New York, loss of that 1,000 megawatts led to electric shortages and outages. And as a result, the unit became fairly notorious. However, over its course of its life, it was a very, very successful unit. And this is a massive diesel engine. Again, being pre-assembled on the assembly floor in West Allis. At the time, it may have been the largest diesel engine ever used for maritime use. And shortly after that, I believe Allis-Chalmers only made 2 or 3 of these large diesel engines before deciding to get out of that business. Apparently, they decided it was uneconomic. And then, of course, Allis-Chalmers is very, very well known for its tractor business. One of the innovations that led to its success is they were the first to introduce the use of rubber-tired tractors. Working together with Firestone, they began using a very low-pressure, tires on the back wheels, and not only was successful in the fields, they advertised it that it could be used when you're traveling to and from the fields. You could travel at speed rather than the lumbersome pace that typically was used by tractors prior to that day, and very quickly led to all of the manufacturers eventually developing rubber-tired tractors. Of course, Allis-Chalmers tractors are well known because of the bright orange as opposed to green and reds and as I think a lot of you know, buying tractors in those days, it was kind of like being a Chevy man or a Ford man. Back in those days, you were an Allis-Chalmers guy or a Harvester guy or a John Deere, and you tended to stay within the family of tractor lines as you replaced tractors. This is a 1936 Allis-Chalmers Model WC, which was a very successful tractor line. They did some surprising research. They, working together with the Space Authority, actually developed a fuel cell powered tractor. And not only that, they developed fuel cells that were used for some, I don't know if they actually went into satellites, but they developed fuel cells technology that eventually led to that application. This particular tractor, I'm told, is currently held by the Smithsonian and is on exhibit in some museum in the Midwest someplace, but it's owned by the Smithsonian, and very significant innovation at the time. And one thing that's probably not well known is, for a period of time, Nikola Tesla worked with Allis-Chalmers. Tesla had developed a patent for a disk turbine back in 1911, and he actually tried to introduce General Electric. He tried to interest Westinghouse in using this disk turbine, and it was unsuccessful in both of those cases. Ultimately approached Allis-Chalmers. He actually met with the Allis-Chalmers board of directors and said, you know, you're going to hear from your engineers that this is impractical. He says, you need to give me the authority to actually oversee this program. He sold the program to the board of directors, and they authorized it. You know, some of you may be familiar with this, but I kind of like this video a little bit. If you take the Tesla patent, and I'm going to overlay on top of this a little video to kind of show how these tightly spaced individual disks would, you know, rotate and essentially take fluid from one leg and take the fluid up to the other leg. And that's, you know, essentially how the disk turbine operated. Pretty simple device, but it was a screamer. It operated at extremely high speeds, and unfortunately, it was not particularly successful. You know, ultimately the Allis-Chalmers engineers were asked to prepare a report to the directors of the company. Tesla was pretty upset, I guess, by the fact that, you know, the company engineers were being asked to report on his innovation and the like. This, by the way, was a photograph of the actual, at least one of the disk turbines that was produced. And you can see two had 20 disks. I guess there were actually 3 of them were produced as part of the contract. But Allis-Chalmers had Hans Dahlstrom, who was at that time a consulting engineer to him. He had essentially retired from the company, but he was asked to prepare a report on the device. And the thing that really caused it to be non-competitive is that its efficiency was essentially held to about 38%, and its high speed, you know, really would have necessitated reduction gears going between the steam turbine and whatever electric motor was being driven by that. And Dahlstrom figured the manufacturing costs were higher than small impulse turbines that could be used for similar applications. So as a result of that, they decided not to pursue the project any further, much to the chagrin of Tesla, of course. And I think this may be one of my final slides here. I find this one particularly interesting. During the Second World War, Allis-Chalmers was called upon to make major components for the enrichment of uranium at the time. And they got involved, I believe, in both the magnetic and the gaseous diffusion equipment. And in order to, you know, of course, this was a very, very highly secretive project. In order to try to keep it as secret as possible, they actually built a wooden wall going through the course of the factories so that the people that were working on components on the left side of the wall wouldn't see the final assemblies that were going on the other side of the wall. So that's the reason for the wall between it. You can see the windings that are coming together here. What's unusual about this is they were using silver. During the course of the Second World War, copper was such a scarce commodity that as they got into this project and recognized the amount of copper that they were going to need for the windings, they determined that there was insufficient copper available, and the Department of Defense, or at least the procurement arm for that, got authority to actually use silver bullion. And as a result of that, there were auditors, there were silver auditors, if you will, assigned to the project to make sure that none of the silver was walking away, to make sure that all of the silver was being used. Following the project and removal of the equipment, they actually took up all the wooden boards that covered the factory floor, and burnt all those boards so that they could recover any of the silver that might have gotten embedded in the wooden floorboards, if you will. And the auditors claim to have been able to account for all of the silver within a couple ounces, I guess. So it doesn't look like any of the silver was pilfered. But Allis-Chalmers, in terms of weight, produced far more products for the Manhattan project than any other manufacturer. And in general, however, the factory employees never really knew what they were doing. They knew it was important. They knew it was important enough to actually build this facility specifically for this use under emergency powers during the Second World War, but they didn't know what the product was. Allis-Chalmers, of course, ultimately went into bankruptcy. This is the site. They went into bankruptcy in 1987. The facility itself was purchased by some of the senior managers in the company and kind of parceled out and used currently for office space. Some portions of the facility are used for shopping centers and the like. And if you look way at the far end, you see a facility called Regenco, and I'll talk about that in a moment. That is the main turbine assembly floor, the main assembly hall. Here's again another view of the engineering offices turned into offices for a medical center. The individuals that actually used this facility for reuse, they actually took some of the overhead cranes, some of the the individual wings, manufacturing wings, actually had the same width as the buildings within them. I don't know why that was designed that way. I suppose the original drafters that were laying it down just found it convenient to use that same width. But because of that, they actually took some of the overhead cranes that were used inside the building, and then used them adaptively to span between the spaces so they could be overhead walkways, if you will. And these, of course, were Pawling and Harnischfeger cranes. This is that main assembly facility that was used for the assembly of all this innovative equipment by Allis-Chalmers all of these years. It was eventually acquired by a group of managers that stayed and formed their own company called Regenco, and repaired steam turbine generator units, not only those operated by Allis-Chalmers, but also by a number of other manufacturers. And then they were more recently acquired by Toshiba. So this is currently used by Toshiba as its U.S. Repair facility, and continues to be in operation to this day. So that's just some of the, it's just a quick overview of two companies that are covered in the book. The book itself includes, as I say, over 70 companies in the Milwaukee area, and I've actually used an opportunity to, when I make revisions to the book, I've been adding additional companies and additional stories. I like this quote. William George Bruce prepared a history of Milwaukee in 1922. And his quote is, he says, there's a great romance in Milwaukee industry. It's got its inception in the lowly condition which existed when many of our present industries were founded. It lies in the transportation of backyard shacks into great factories, from the tumble-down huts where some gritty man with real vision started fashioning with his own hands some article which would be useful for mankind. Today, those little enterprises have forged ahead into huge industrial units of the city. Says romance, I'll tell the world it is. I think it's a very, very fitting quotation to use at the end of the speech here. The book itself, if you're interested in either these two companies or other aspects of Milwaukee history, the book is available for sale. Probably the easiest place to get it these days is during the lockdown is at Amazon. It sells for $24. And Len, that's it. If there's any questions or comments, I'll be very happy to address them at this time. And I guess I should probably stop my screen sharing.
Yep, that's fine. No questions so far. We'll give it a minute to see if anybody writes in. You actually answered one of my questions, was where can we get the book? Are you working on any other books or anything that you're currently working on for industrial history?
Yeah, I'm actually working on an activity with the War Memorial Center of Milwaukee. This is the 75th anniversary of the end of the Second World War. And we're working on an exhibit that, I'm essentially helping them curate the exhibit of Milwaukee manufacturing activities that, into the Second World War that led to our success. So it's talking about the building of engines and ships and other things during the Second World War and how Milwaukee industry contributed toward all of that. And I've been working on a series of monthly articles on the subject, talking about various companies, kind of one by one. So that's getting a lot of additional publicity and the like. And from time to time, I, as I mentioned earlier, I've been continuing to explore various aspects of Milwaukee industry. The latest one I'm working on is a company that pioneered the production of multicolored printing presses for large volume, for advertising inserts, and eventually for newspaper, to enable them to be printed in color. And a lot of that occurred a couple miles from here in Milwaukee's River West neighborhood. And I thought it'd be interesting to document their contributions toward all of that. And then the book itself, I self-published it, which has provided one advantage, which I didn't anticipate when I started the process about 5 years ago or so, is that anytime I want to make a change to it, I've got complete control, so I can add
turn off a whole new batch.
Yeah, since the original book came out, it's probably grown by 30 pages or so as I, to come across either other stories about innovation in Milwaukee, other companies, or other great photographs. I've been able to include a lot of those, so it's grown over the years. Very
cool. I mentioned earlier you're part of the History and Heritage Committee for ASME. For those of the people out there that don't know, can you explain a little about ASME and what you guys do as part of the History and Heritage Committee?
Okay, well, ASME, is an organization of mechanical engineers, and it originally started as a United States organization. It's morphed as, essentially into the mechanical engineering society to represent mechanical engineers and mechanical engineering science across the world. It's probably one of the ways it's known is because it develops a lot of the standards and the codes that really allow things to, like pressure vessels, to be built safely, or elevators to be designed safely and appropriately. And a lot of that work goes into standard developments and the like. But there are divisions within ASME, power divisions and various other technical divisions where those that practice together can get together and discuss their trades, if you will. And the History and Heritage Committee was formed, I believe, in about 73 or so. And, we of course, document significant engineering accomplishments over the years. And we try to, to look for machinery that has been built over the years that are very particularly significant, and then landmark those machines so that they're not forgotten, and hopefully that they'll be preserved. And to date, I believe we've had about 265 landmarks located literally across the globe. A lot of them, of course, are in the United States, but we've got landmarks in every continent, and it's been kind of interesting. I've been with the committee for it's probably about 14 years or so, and we've had landmark ceremonies in Italy and in England, and we're working on hopefully landmarking the development of the auto industrial, the auto internal combustion engine, and the first one of which is located in Cologne, Germany. So we're hoping we're able to pull that together over time.
Very cool. Thanks so much for joining. I don't think we had any other questions from the Facebook crew, but thanks again for joining us. For anybody that's watching live, you can check out some additional programs that we're hosting. Again, we're hosting a program tomorrow afternoon about the large crane that's in the National Museum of Industrial History. So if you've ever been in the museum and in the lobby and looked up and saw our giant crane, our historian's going to be presenting a little bit about that. And then next week, we're going to be doing a tour virtually of the Allis-Chalmers engine, which is located in Phillipsburg, New Jersey. So we're very excited about that. And again, if you're willing and able to help the museum out right now, continue these talks, continue our behind the scenes work to save artifacts while we're shut down. You can check out our website at nmih.org. You can purchase a museum membership. If you're shopping on Amazon, for instance, for Tom's book, you can select, you can use smile.amazon.com instead of regular amazon.com. Select the National Museum of Industrial History as your charity of choice. And part of your purchase, with no extra cost to you, will go towards supporting the museum, of course, as well as the author. So thanks again, Tom, for joining us. And thanks for everyone out there who tuned in. And have a good afternoon.
Good. Thanks all for the opportunity.